Today we're going to be doing some body routing. Are you guys ready for part 8 of the Strat style guitar building series that I'm doing? At this point it starts happening pretty fast because we're going to have a body shape pretty good looking at the end of this episode, and then we already have the neck and it's going to start looking like a guitar. This is when guitar building starts really getting exciting. Truly, this is the fun part. Now I've got 2 different template sets going on here. One, the alder body, we are going to make in a conventional way with the top loading, the pickguard, the whole works right there. The other one, what I called my environmental series, the laminated leftover pieces of body blank that we have together, we're going to use a rear access version of the template. If you're not familiar with these templates, go back and look at the link below of my template series, okay, because it goes over what my templates are all about. Now, if you have other templates, what I'm going to teach is mostly compatible with that. So there's good, solid information for sure for any of you. But if you're one of the ones that have already purchased some of my templates or in the future plan to, then this series is really customized specifically for you, exactly the way the students that I teach at the local community college, because when I teach guitar making there, 101, I require a Strat or Tele build, and this Strat style guitar build series is designed specifically the way I teach it at the school. So hopefully you'll follow along and things will make sense to you. In another video that I did recently, I pointed out my new guitar top glue-up jig that I'm selling on the website. And a lot of you took advantage of the pre-order pricing, and I got a really nice response to it. So if you haven't got this, if this is way on down the road, still check it out. I have a feeling that it's going to be a popular seller over time. But in that episode, and the link is down below to this episode where I glued up this top, is I offered for the subscribers to pick out the guitar top, the walnut, Claro walnut guitar top that is going to be used on my environmental series rear cavity Strat style build. The results were kind of split. The winner seemed to be one of these tops that has a lot of stress fractures in it, and everybody wanted to see what I would do with the cracks and how it would be incorporated into the design of the guitar. So that is what we're going to do. Now, unfortunately, the one that got the most votes was actually sold because I forgot to delist it from, is it delist or it'd be unlist? Okay, I forgot to remove it from our website and it ended up selling. So I have found the next closest one that was similar to that, and this is the one that I am going to be using. I think I still have to take that off the website. Anyway, don't buy it if you happen to see it, because I got to take it down. But I'm going to use this one for the environmental Strat style guitar build series. Now we are going to go into the actual glue up and the filling of those cracks in a separate episode that's going to air sometime after this one, because there's a lot to talk about there, and I don't want to just cram that information all into the same episode as just the routing of the guitar bodies. So that will be a separate episode. But that's what we're going to do with this one. Let's get a close-up here. This is actually the guitar top. I actually graded it out as a grade 2, but this is probably a grade 4 because of all of the color variations and the figure in here. This is going to be an amazing top, but it's the stress fractures in the wood that cause it to be maybe a little less valuable from a purchasing standpoint, but could be even more valuable from a finished guitar standpoint. So when you're using my template system, one thing that is different from any other template system that you've probably seen, to my knowledge, is that I use off-body alignment points, okay? And generally speaking, I place them wherever the strap buttons would go. Not that it's important exactly where it is, but I do like that they're not perfectly in the same center line. And the reason is that way the template never gets confused about what is the top and what is the back of these clear acrylic templates. I've had students in previous template versions of mine accidentally make a left-handed Telecaster guitar body because they had the template on the wrong side when they did the work. So because of that, when I do this off-centered, off-body alignment pin system, it reduces the confusion. But these hardened steel, and these are custom made for me, hardened steel drilling bushings are heat set into this acrylic, so I don't care how many guitars you make, you're not going to wear out these drilling bushings as the drilling process. But the first part of what we are doing is drilling the two locator alignment pins. And so in generally speaking, what we're going to do is take and put the center line of this template right in the center line of the wood. Now this happens to be a one-piece chunk of alder, so really it doesn't matter. I am just going to place it in the best space for whatever imperfections there might be in the wood and keep it generally in the center line, and that will be good enough for our processes right here. Now, some people are a fan of double stick tape, some people are not. All right, I've got some here that I'm going to put on the back of this template, and just 2 or 3 pieces is enough. In this particular case, my alignment pins will always hold everything perfectly located without any torsion or sponginess left or right. So I'm not worried about the double stick tape from a standpoint of holding the template perfectly still. However, when I go to set my anchor points, the 2 1/4-inch holes that I'm going to drill for my templates to pop onto, I want to locate it in the proper position with a little bit of tape so that while I'm drilling one hole to the second hole, that the template doesn't shift and all of a sudden those 2 holes are not in the exact distance needed to be to pop this template right into place. In this particular case, since we've got a one-piece body, I don't really have a center line that I'm working towards. So I am just going to position it somewhere close to the center line, away from as many of the defects as possible, which there's not many. This is a pretty nice piece of alder. Now, once we have that in the proper location that we want to build this guitar from, now we go and we drill these holes. All right, now the tricky thing about drilling these holes is because the Stratocaster has some templates on the front side and some templates on the back side. For instance, like the rear spring cavity. Those things need the template to be positioned on the back. So what we're going to do is take these holes and we're going to drill them all the way through this 1 3/4 body blank so that we have references of those pins on the front and back. Now, generally speaking, I would say this is a drill press job. All right, and so if you have a drill press, you're going to have to spend some time to make sure that that drill bit reference to the table is perfectly square in both directions so that when you're drilling a hole, it's truly going straight. Now, can you do it with a hand drill? I suppose you could. Maybe if you had one of those contraptions that kind of squared it up, as long as it was set up and it was going right. I even saw something recently where someone was able to drill perfectly straight holes by using something reflective, and I was thinking of maybe like a piece of plastic, like a pickguard material that has a mirror finish on one side, and drill a hole in it, put that over top of this area, and you can drill it straight because you'll see through the mirror whether the drill bit going in and the reflection of the mirror is perfectly straight. If it's off to one side, then the drill bit's not straight. And I haven't tried that technique, but for those of you that may not have a drill press, I'm thinking this could be a good solution. And maybe I'll show that in a video at a later time after I give it a try for myself and see how well it works. It's the same principle that if you're using like a Japanese pull saw, is you're doing the same basic thing where you're looking at the mirror finish on the side of the blade and how the piece of wood is reflecting in that. If it looks perfectly straight, then the cut is going to be straight. If it looks like it's contorted, then your saw is not perfectly perpendicular to the surface being cut, and therefore you're going to see it. So it's the same principle, and I think there might be some validity to this, even though I've never used it myself. But just an idea for those of you that may not have a drill press, or one that you might not think is up to the par of drilling holes through almost 2 inches of material in a straight manner. All right, if you got your drill press and you want to make sure it's straight, this is one of the more traditional ways to do it, is to take your square and make sure that on all sides, when you bump this up, that you don't have a gap. That's perfectly straight with that bit. And if you check that and it's square, then you're good. If not, you may have to adjust your table and make sure that left and right, or front and back, if you have an adjustment to do that, is good. If you do not have a front and back adjustment and the front and back distance is not perfectly square, you may have to put a piece of board down and shim it out in order to get it perfectly square. So that's up to your equipment, but the key thing is when you go to drill these alignment pin holes, that you are drilling perpendicular to your body blank. If you want to be really fancy, you could use one of these digital scales, digital angle gauge for this, and this could certainly work out. We could set our 0 point for the surface and now we can extend our quill out so that we have something steel and flat right there, and just click it right on that, and we can see what that angle is. And that is right on 90 degrees. So 90 degrees from that to this being 0 tells me that that is perpendicular. And again, we want to check it in all axis just to make sure that left and right and front and back is perfectly square. All right, so here's a little tidbit for you. When you go to insert your dowel pins, you want to insert them all the way down and to the bottom of the wood, and then we're going to use a flush cut saw to cut that off. But these can be really stiff, and depending upon where you live and the humidity level of where you live, these dowel rods that you buy might be too tight. If a round peg doesn't fit in a round hole, then you need a bigger hammer. No, you don't. That's the problem, that if it's too tight in there and then you're trying to get the template back off of that pin and you're flexing the acrylic, you could snap the acrylic, okay? It's not bulletproof, but it's very durable if you use it the right way. So in your area and whatever dowel pins that you have, you want it to be snug, but you don't want it to be so tight that you can't push it in with a little bit of strong hand pressure. So let me show you a little technique. All right, this little thing is called a dowel sizing plate, and it's got all your standard sizes on it. This is a handy tool to use if you're working with dowel pins, and you will be working with dowel pins if you're using the Maximum Guitar Works template system. So what you want to do with all of your dowels is, before you start using them, is just to make sure they're sized correctly by putting the dowel through that plate and tapping all the way through the plate. And what you'll see is sizing taking place. Once it's properly sized, then you'll notice that it will go in without as much pressure. A little bit of tap, and it'll go right in and it'll be snug, but it won't be too tight where it creates an issue getting the template back off. Again, this is preventative care so you don't break your templates, but all you need to do is move it 1/4 inches down with like a little flathead screwdriver and tap it the rest of the way into the wood, and that will free up, as opposed to breaking off your template. It'll free it up so it goes a lot better. So the other thing that I like to do with the templates is, did you see that? I almost had it on there backwards, but it won't fit. See, that's what I was telling you earlier. That works pretty well. I'm going to take and pop the template back onto those 2 pins. Again, really snug fit, but not over tight because I sized the dowels properly. And I'm going to trace out the profile. Okay, this gives me a way to either take it to the bandsaw right now and cut it out, or at least have a reference of where my guitar body is so as I begin the work. Now I can go ahead and trace all these other cutouts, but it really doesn't matter because the template system is going to take care of the alignment automatically. I could take it off, put it back on, time and time again. The template is always going to fit exactly where you established it on your center line. Now is an important time to talk about something near and dear to my heart. In the pilot world, we call it sequence and timing. In manufacturing, we call it order of operations. It's basically the same thing. All right, we have to determine what is the best flow of the work to do routing, profiling, all these different operations, and we have to figure out the best way to do it. Let's pause and talk about the documents that go along with this series. All right, this is task by episode, this is an outline, this is a parts list of all the things you're going to need if you're going to build a Strat style guitar. And these are materials that I have mentioned time and time again, and I will mention it again, that if you would like to have digital copies of these materials that I use in my class and in building a Fender style guitar, like the Strat type guitar we're doing in this series, all you have to do is email me. Go to the website. There's a link right there. Down below, you'll link to our website and you'll see contact us, and send me an email and say, hey, please send me the documents that go along with the Strat build series. And I will send you these documents, but they might help you with that order of operations that we talked about. And so the interesting thing is sometimes order of operations is absolutely critical, and other times it's personal preference, and you have to kind of figure out the whys of that. So in this particular case, it doesn't really matter what I do. I can cut out the body, I can profile the body, I can come back and I can do all of the internal routing and the neck pocket and everything like that. Or I could go ahead and knock out all of the routing right now and then get back to the body later. So it doesn't really matter. For this particular one, I'm going to demonstrate doing the profiling first and then the neck pockets and then the pickup cavities. On the other guitar that we're building in this series, I'm going to demonstrate the reverse. In a sense, I'm going to put in there any routing that we need to do to this guitar first before I remove the profile. Now, the reason why this one, it might be a better idea to do it the other way is because this guitar is going to have a top on it. And therefore, since it's going to have a top, what I can do now, while the body is still square, is I can do all of my wire route channels and anything else that I may want to do to go along with that. But let's come back to that one. And this one, let's kind of knock out the profile and show you how that's done. This gives me an established line that is outside of the profile because the pencil width is right wider than the profile. So as long as I stay outside of this pencil line, I'm going to be outside my final body shape. So I can take it to the bandsaw, I can cut it out, and I can start from that point, and then I can flush cut this and then begin the process from here on. Okay, with this alder body, we've got the template back on in place, and we made our bandsaw cut within a couple millimeters of the edge so we don't have to remove a huge amount of wood. And you'll notice I don't have any double stick tape on this whatsoever. All I've got is 2 pins, and I've got these paddle grips that are used to control the wood as I work around this 2-inch router bit. And this is what provides the safety. These are standard with all Maxim Guitar Works template systems. For all the profile routing, have the ability to mount these paddle grips right to them. So when you get these, a lot of people are surprised, oh, I didn't know it included it. Yeah, it includes it because I care about each and every one of you being safe. So everyone should be using something safe like this in order to keep their fingers from being out of the way just in case something unexpected happens. So we're going to go ahead and route the perimeter and be all set. I don't know about for you, but for me, tools are fun. I mean, there's nothing more enjoyable than being creative, and wood is just a great way to exercise that creativeness. We just got done the router table, the profile. Now again, this series is built for the students that I teach in class, and they have access to a router table. I know some of you don't. This can be done with a handheld router, but I tell you, you should do it in multiple passes and only take not the whole bite at once, but just a little bit of bite at each pass, and then step your way down through the entire piece of wood along the template. The thing about it is you really need to make sure it's clamped and stable so that it doesn't slide and move around if you do it that way. But I would strongly recommend a router table. I'm using a router table that's 30 years old that's got just as old of a router in it, and it still works fine. So, you know, it's like, why try to improve something that's still working great for me? So it's not that hard to get into that, and if you take care of the router table or the procedures in which you use the router table, you'll get great results. When I designed these paddle grip systems for my templates, it was for safety for my students. But the thing I did not realize is that my students were going to get a much smoother cut than when they were trying to handle it with their own bare hands holding it down. And that's because the positive grip allows you to stay connected with that bearing more solidly, and consequently it produces a smoother finish to your cuts. Now alder is still a difficult wood to work with because it's got surprises in it, and honestly I generally don't use alder if I'm going to have a clear finish on it or a translucent finish. Now certainly you can, and you can get lucky and get some good alder. Like this is really nice looking alder here along this end grain, which is where the problem normally is. Looks really good. However, if we come to the tail end of this guy, we see a little bit of internal checking or fractures that were inside of the wood that I couldn't see from either surface before I cut it. So you don't know it's there. It's the other problem with using a one piece is it could be buried deep inside and then causes these little fractures, which won't make a transparent or a clear finish as desirable for you. Now, another thing that's important is for you to be weight conscious. maybe not your weight, but at least the guitar body weight. I once had somebody comment on one of my videos that I was old, fat, and ugly. Well, that kind of hurt my feelings. I went and asked my wife about that, and she said, honey, you're not that old. So I like to weigh the bodies along different stages to develop an idea of what the weight is going to be and what good proportions has been for me consistently in the past. And again, like I mentioned in previous episodes, I really try to maintain a certain proportion. Now this body is shaped, but it hasn't lost all the weight that it's going to lose. A portion, but not all of it. So we're going to take that into account, but let's start measuring here. Okay, I have got 5 pounds, 2 ounces right now. Now here's a critical thing. When I lose the extra weight, and I could calculate that if I wanted to by calculating the square inches of material that is going to be lost and the approximate weight based upon the size of when the blank was square or what have you, and I can figure that out. But you do it enough, you kind of get a good feeling about things. So once I lose all the weight of the forearm contour, the belly contour, the roundovers, the pockets, and everything like that, I'm probably going to be in the low 4 pounds. You know, 4.2 to 4.4 pounds. Okay, that's my guess. Don't hold me to it, but if I'm right, I'll be sure to take the credit for it. All right, but so I'm going to be somewhere around there based upon a 5 pound, 2 ounce weight right now for this piece of alder. So let's talk a little bit about weight control or weight reduction and why. All right, so here's a rule of thumb. If I weigh the neck that I produced for this guitar already, and it's got the frets, but it doesn't have tuners, and likewise, when I weigh this after all the routing is done, it won't have hardware in there. So I'm sort of going apples to apples and just counting most of the hardware as just balanced weight, all right? So if I look at that, I am 1 pound, 1 ounce here, and the typical rule of thumb I like to be on neck to body is about 1 to 4 is the ratio. So therefore, if I'm 1.1 here, if I'm somewhere around 4 pounds, 4 ounces here, I think it'll be a really nice weight distribution once all of the hardware is added. Now, certainly different hardware can vary. You know, if you're using a tremolo as opposed to a hardtail bridge, that's going to add more weight and things like that. So I'm not talking about laws as much as rules of average or rules of thumb averages that I have found to be true in the planning weight. So if I was significantly higher than that proportion right now, or projected to be at that proportion once the rest of my routing is done, I may want to consider some weight reduction. Since I'm painting this totally opaque, I could resaw a 1/4 inch off the top. I could hollow out the inside. I could put the top back on, and I'm right where I started with, except for a little bit lighter. And if I was going to do that, I would probably do it before I cut out the perimeter. So I should be checking my weight all along. Now this is feeling pretty comfortable to me at this point in time. So we'll see. 4.2 to 4.4 pounds is where I'm guessing this will ultimately be, and we'll see how it works out. Okay, I just got back from the drill press, and technique is just to rout out with a Forstner bit as much as you can of what you're going to be routing out with a router bit. And it's not something that you absolutely have to do, but it will save your bits. Less wear and tear on the bits. Let a drill bit do what a drill bit does and hog out all that material, and then you can clean up and set the depth. Now I will tell you, using a Forstner bit, the little point at the bottom is about 1/8 of an inch deeper than the flat spot of the Forstner bit. So you want to stop at least 1/8 of an inch prior, or you're going to have little tiny dimples in the bottom. All right, so we want to take care of that. The other thing we want to double check is, now that we're getting ready to route out our neck pocket, you want to make sure the fit is good. So it's as easy as taking the heel and sticking it in the template and seeing if there's any room left in there. And there is just a little tiny bit of room. So what we're going to do is we're going to take up some of that slack in the pocket with some binding tape. And it might seem like a broken record because I've done other videos and I've said the same thing, but this is just a precaution because you can always take the tape off and you can make that channel slightly larger. But what I want to have is a really snug fit where it just barely fits in there with the tape. And I think I'm right at that point. If I need to take more off, I will certainly do that. Now, the other cool thing that you can do is when you cut out your body blank on the bandsaw, save those pieces, and the template itself is held into place with these two pins, as you'll remember, but this end is out pretty far and it can flex a little tiny bit. Would it make a difference for the pocket itself? Probably not, but I feel a lot better if I just slide with some double stick tape that piece of wood that's the same height as this back underneath, and now I've got a much more rigid platform for my router. All the key dimensions are engraved right onto these templates, so you don't have to worry about forgetting what that is. Now, the first one is the neck pocket at 0.625. That's 5/8 of an inch. Now, I will caveat that everything in guitar making depends on something else, right? In this particular case, the standard Fender style neck is designed to be from the crown of the fretboard to the bottom of the flat spot there to be 1 inch exactly. If you are 1 inch, then that's the depth that you're going to need. If you just happen to build a neck that ended up being, let's say, 1 1/4 inches, well, then that extra quarter needs to go deeper in that neck pocket, and vice versa. If your neck was a 1/16 of an inch thin, maybe you don't want to go a full 5/8 inch depth. Okay, so it depends. I'm going to set up the router so I can only plunge the 5/8 exactly. This happens to be a metric router, so I'm going to set it up to be right around 15, which is a little bit less than the equivalent of 5/8, which would be 15.8 millimeters roughly. So that should take me exactly where I need to go. And who here remembers the lessons that I previously taught? How deep do we set the router bit for the first pass? So to answer the question, I basically want from the flat surface about half of the bearing exposed that's going to ride on the template, and that'll give me a nice clean cut on my first pass and make sure I'm not too shallow that I dig into the router. You got to be conscious of where that bit is cutting and make sure that it stays at a point that the bearing or bearings in this case makes full contact. I would say not full contact, but at least some contact with the template. And I prefer a minimum of about half of a bearing. Here's the other nice thing about this alignment pin system is I can take this off right now and I can test fit the neck. And if that neck is too tight, then I can take the tape off and do another pass. This is feeling pretty good, but it might be just a hair too tight. So I think I'm going to take off one layer of tape and I'm going to route again. Oh, that is what we want. I mean, did you see that? It's snug. There's no wiggle room whatsoever. But it's not overly tight. It will get a little tighter in the end because when we apply finish to the neck, it will get a little bit tighter, but it won't be much. So I'm going to tell you right now the difference between too tight, and perfect. That was 2 pieces of tape, 1 on each side, which is 12 thousandths of an inch. 12 thousandths of an inch. That is the type of crazy tolerances that you have to work within to get the best possible results. I love this fit. I love it. That is incredible. So we are done with that one. We're going to move on to the next pocket. Same exact thing, just a little bit deeper. We're going to go 1.5 inches deep out of a 1.75 inch top. I may or may not be able to get it all with this bit. If I can't, I will stop short and I will either switch to a longer bit, or I will take this template off to continue the process. All right, we got 2 down. 1 more to go. Now this guy, we're gonna go at least 1 1/8 inches deep. And that is because the rest of it will be gotten from the backside. And as long as we go that deep, we will easily be able to reach what we did from the top, from the back, and not have to do any complicated cuts. The hardest part is starting the bit inside of one of these drill holes. So we're just gonna be careful, huh? All right, what should we do next? I say while we're on the front, let's go ahead and knock that guy out and that guy. For this, we can come right back to our main body template, and all we've got to do is remove the paddle grips, set those aside, and now we have access to this. Now, again, we're going to do the same basic procedure here, and the easiest way would be to drill that hole out and then kind of work it from there. Just to save a little time, I'm actually going to just take it directly all with the router bit just to show you that it is possible. Toughest part in this one is to plunge the initial bit in without hitting the template. Wish me luck. Okay, I cheated. I took the dust chute off because it's really hard to see with the dust chute on there. And now we are going to clean this up and then use the dust chute for the rest of it. Oh, wait a minute. We forgot the pickups. Or is Steve going to do something really tricky? I mentioned this in a previous video, but we are going to use the new Maximum Guitar Works Stratocaster swimming pool route to take out a larger chunk. We are going to get additional weight reduction, and we are going to get the flexibility to add whatever pickups that we want inside of here. This is a 2-piece kit. The main swimming pool is going to go 0.75 inches deep. Then we've got a separate template that uses 1/2 inch guide bushing and a 1/4 inch router bit to make the extra little space that we need, about a 1/4 inch extra, just in case it's required for humbucker style pickups, space for the legs. And so we are going to do those back to back. But since we're taking so much meat out of this guy, I'm just going to go hit it with the Forstner bit and be right back. All right, shall we? I'm not sure if that was a strategic camera position. You probably saw my forearm more than anything, but there's our swimming pool route right there. Are you getting how these templates are hot swappable? I don't have to map out the center line. The center line's set on the templates, and I can bounce back and forth really that easy. It's pretty amazing. Kind of simplifies the process. It's almost not fair. I should probably stop making these. It's not fair that people don't have to be frustrated with center lines and things like that. So we've been using my special pattern bit concoction, the 1/2" mortising bit with a 5/8 bearing removed and 3 1/2" bearings added. We've been using that for all of this so far. So Steve, why don't we just continue to use it for this? And that's because it gets really difficult to keep the bearing on the template as you're going too deep. So what's better, especially for narrow openings like this, is to use a bushing guide that will then ride in here, and then I can start it with the bit fully retracted and then plunge down to where I need it after I get it in place. And it's a lot safer to do it that way. And I'm not sure if you're aware of this or not, but Steve's all about the safety. What's that mean when I start talking in the third person? Same exact process here. I'm going to bottom out the bit, and I know I want to go another 1/4 inch for the pickup legs, should I be using humbucker. And in that case, 1/4 inch would be about 6 millimeters. So we've got 6 millimeters dialed in, and now we are ready to go. See if you can see better from that angle. That, my friends, is a good fit right there. Of course, you'd like to see a close-up on this. Neck pocket, swimming pool route, including extra room for the legs there. Electronics cavity cover, the beginning of the tremolo route, output jack. She's coming along. All right, you'll hear different things about swimming pool routes, and a lot of people say, man, with the swimming pool route, the tone improved. Well, you know what? It may be the case. I don't know. I don't really do this in this particular case for any specific reason like that, other than the versatility of using a pickguard with almost any pickup configuration that I want. And that's kind of the advantage of it for sure. So if you like the traditional route, then go ahead and use the traditional template. If you like the idea of a swimming pool and the versatility that comes with it, then get the add-on template system for the swimming pool route for the Stratocaster. Uses the exact same alignment pins, drops right in, perfect alignment every single time. And that is really what we're after, isn't it? Stress-free. Let's do the back. Now we're ready to move on to the back template, and there's several features here that are just really cool. Let me be serious with you just for a second. I have gotten so much feedback of people who have purchased these templates that are getting great results from them. They appreciate the quality, the attention to detail and features and stuff like that. And if you're up in the air, if you're looking for a way to get going and building guitars and you're looking for a template system, I'd ask you to purchase mine. I think they're the best out there, bar none, because of all the features and all of the detail that goes into them. And where else are you going to get a complete, overly detailed explanation of how to use these templates or any templates to do your guitar building? I mean, that's really the bottom line. So I try to provide this to make it as easy, and the templates, again, are to make things as bulletproof as possible, as repeatable as possible, and as safe as possible. The features on the back template is obviously the spring cavity route. That's the most important thing. The trickiest thing with that in normal template system is how do you line up the back with the routing that you just did on the front? Okay, you can do it by trial and error. You can try to plunge all the way through, which I used to do, from the front all the way down to the back, and hopefully you can make that slot so you can line up this template. But it's never going to be perfect, but you can get it pretty close. But it is painstaking and increases the opportunity for error. So because the alignment pins pass from the front to the back, there is no guesswork, there is no double stick tape, there is no masking tape and the super glue trick. You just press this down on both of those pins. Center line is the center line, whether it be the front, whether it be the back. Now, another feature that I built in to it is this slot here. Well, this feature is not used on the back, it's used on the front. It's if you're going to use a spoke wheel style truss rod at the heel of your neck, then this creates a little notch out on the front side to clear away the space for that spoke wheel to drop right in the place, and then the pickguard just kind of do a little half moon right there with maybe an oscillating spindle sander, boom, and then it just slides right in perfectly. So that's a feature I was able to fit on the back because there was space, but it doesn't matter whether it's front or back because these templates are interchangeable whether it be either side. And the other feature I put on here is just a guideline for a belly contour. This is a very appropriate belly contour for a Stratocaster style guitar, and if you mark that and then you'll have to carve it by hand, there's not a template for doing that exactly, although I might be working on something. So you need to kind of go ahead and subscribe. I'm not afraid to say it. I generally don't, but you know, hang out with me, check it out, and in the future, if I'm able to come up with a way to do that, which I just might, then you'll be here and ready to see it. All right, so we are going to do the same deal on the tremolo spring cavity. This is going to be 5/8 of an inch deep, so we can drill this out to be about a 1/2 inch and clean up the rest. But I'm just going to go right to town and just hog it out. All right, here we go. Now, if we look at this, we've got a ledge on the back side. Now this is going to be the trickiest part here, is we've got to take this ledge all the way down to about 3/16 from the front. And we have to do that without touching the front side. So I went 23 millimeters in additional to the 16 millimeters we went for the spring cavity. And that ends up producing a total depth of this right here, which you'll see the collet is still below the surface of the router. That means I can, in fact, extend it all the way down. You must double check this. If you do not double check this and you just keep going further and further and further, thinking that you can just go all the way to the other side of the world, eventually that collet is going to come up, and that is going to rub on your template or the wood if your template's not on, and it's going to mess things up. You got to double check that. It's right at 3/16, so that's where we need to be. All right, here's the back. We do have one blemish in the wood, but I'm thinking that's going to come out in the belly carve. And there we go. Spring cavity, 5/8, passing all the way through to 3/16 from the front. Perfect connection right there. And on the front, got everything we need for an awesome Strat type guitar. All right, this is really the bulk of the process that was designed in part 8 of this series. Now I've got 2 bodies that I'm working on. The other one will be similar, but it's different. And in order for this video to not go too long, I'm going to separate it into 8A and 8B. This will be the A. The next one will be the laminated body that's going to have a top on it. and we're going to do the routing of that because it's slightly different order of operations to get the best possible results. And instead of dragging this on after everyone is losing attention span, because the average person only watches 10 minutes of my videos, even though they're much longer, we're going to stop it here. We're going to come back with 8A. We're also going to do a separate video on the side, not really part of this, but talking about filling the cracks in those Claro walnut tops. And then after that, we're going to get on with both of these tops to part 9. So part 9 will deal with any type of roundover or forearm contours or bevel cuts and things like that. So until 8B, that's coming soon to a YouTube channel near you, remember, no matter what you do, start with excellence.